Okay, so what are we going to discuss today is an interesting topic called conditional probability. So now conditional probability means involves a condition, obviously as it says. Condition is condition that something has already happened, right? Now let's take an example. I will, let's say, draw a Venn diagram and I say that's my sample space, that's my universe. I say I've got, 1, 2, 3, 4, 5, 6, 7, 8. This is my sample space, correct? Now, let us say I have chosen a few elements in the sample space, right? And I call this as set B, right? That's the first activity that I've done. Now I've gone and again chosen something within this set, and I call this as A. So basically, A is a subset of B, correct? Now, what exactly have I done first? I chose B, right? And then I chose A. So if I were to summarize what I've done, I have actually chosen A given I have chosen B already. Is that a fair statement to make? I've chosen A only after I've chosen B. So B has happened before A. Choosing of B has happened before A. So this is what conditional probability is all about. So we're talking about a condition that happens before the final selection is made. Here, B was chosen before A was chosen. So that's the condition for A to be chosen. So I need B to happen before A has happened. So that's why I say this is probability of A. What is the probability? If I were to reiterate that in terms of probability, I can say, what is the probability of happening of A or choosing A out of this universe given B is chosen already? This is called conditional probability in its laymannish terms. And this is how I represent it. Probability of happening of A, and there's a bar between A and its condition. And I say probability of A given B. Now, if you look at, so is this, that's the basic fundamental meaning of conditional probability. Now, if you look at set B here, and we just said that A is a subset of B, that means there's something which is common between A and B. So there has to be an intersection between A and B because A is the subset of B. So probability of A given B is what? Now, if you just for 1 second, if we just step back and I say, now for A, for choosing A, let's say, for choosing A, my universe is just B. Now assume my universe is just B. So let's say B is my universe of 3, 5, 7, 6, and 8. Now out of B, I'm choosing A, which is 6. So A is 6. If that's a very bare minimum scenario, what is the probability of choosing A? What is the probability of choosing A? A, which is basically how many elements are common? How many elements have I chosen in A? Only one, right? So n of A is 1 over n of B. That's my probability of A, correct? Because B is my sample, B is my universe. If you look at B and I ask you what is the probability of getting 6, so you'll say 1 on 1, 2, 3, 4, 5, 1 on 5. This is what I've exactly asked right now, 1 on 5. Now, coming back to conditional probability, what is the probability of A if B is my universe? So whatever is common between A and B, which was actually 6 here, over probability of B, all of B basically. Now, why I have included the probability of B here and not its number? Because we're talking about, now B is not the universe. Now the universe is actually epsilon here. So that is why probability of B comes as denominator, because the universe changes. So this is a very laymanish explanation of why this formula looks like that. So again, to summarize, B is a condition to happen for A to happen. B has to happen before. And conditional probability tells me that if I have to find the probability of A given B, I have to find the common between the two first over what has already happened, the probability of something that has already happened. And why this is the case, I've just quickly explained it here. If I change the context of my universe and I start selecting only A, this is how it is. So, and one last thing, if I flip this to, I say probability, what is the probability of B given A? Let's say now this is not my context right now, my universe is changing. Now I'm just explaining how the formula works. So this has nothing to do with this Venn diagram now. So I'm just telling you how the formula changes when you flip these sets. So again, on top, it will still be A intersection B. But then whatever has happened before needs to come as the denominator. So because I'm finding the probability of B given A, so I must know the probability of A. That is why it has come into the denominator. So that in very, very general terms, very simple terms, is how conditional probability works, in its very simplicity.